Section 3.5, equations of parallel and perpendicular lines. So in my opinion, section 3.5 is a nice little break. It is geometry, but it is primarily also review from algebra. So these are things you have seen before in this section, with just a slight geometry twist on it, but nothing terribly new. So the first one, slopes of parallel lines. If two lines are parallel, they have the same tilt to them. And another word for the tilt is the slope. So if lines are parallel, they have the same slope. It makes sense though. They would have to, just think of like, lines on a road. If they're parallel, then they're pointed the same direction. They have the same tilt, the same slope. Lines that are perpendicular do not have the same slope. And it would be normal, like the first instinct is to say that they are opposite slopes. If one has a slope of 3, the other one would have a slope of -3. But what happens if you get something like that, your lines start to look like this, and they're no longer perpendicular. In order to have them be perpendicular, the slopes must be opposite reciprocals. So, I'm taking a guess here that you know what it means to be the same, but to be opposite reciprocals is maybe some vocab that you might not know, or perhaps your teacher last year or last semester used different vocabulary. So an opposite reciprocal, the opposite reciprocal of 4, opposite means change it from positive to negative or negative to positive. Reciprocal means to take your number in fraction form and flip the fraction. So the top becomes the bottom, the numerator becomes the denominator becomes the numerator. The opposite reciprocal of 4 is -1/4. The opposite reciprocal of -2/3 is 3/2. The fraction flips and it goes from positive to negative or negative to positive. Slope-intercept form is one of the things you probably remember the most from algebra 1, probably in the fall. Y equals mx plus b. M is the slope, and b is the y-intercept. It's called the slope-intercept form because when you look at this form, you immediately see the slope and you immediately see the y-intercept. Slope-intercept form is typically how you're going to write your answers. Point-slope form, your teacher may or may not have covered very much. It's one of my favorites when it comes to algebra. It's called point-slope because when you look at it, you immediately see a point, which is x1, y1, and you immediately see the slope, m. Yes, your teacher may have taught you to use slope-intercept form every single time, and that's not wrong, and you can do that if you want, but point-slope form is designed for when you have a point and a slope. So anytime I have a point and a slope, I'm going to use point-slope form. The other equation that you might want to know or need to know from algebra is that slope, m, is equal to rise over run, or y2 minus y1 over x2 minus x1. This formula right here and y equals mx plus b are some of the things you probably remember from Algebra 1. So example 1. Tell whether the lines through the given points are parallel, perpendicular, or neither. Justify your answer. So let's see here. In order to know if they're parallel, perpendicular, or neither, we need to know if they have the same slope, they would be parallel. If they have slopes that are opposite reciprocals, they would be perpendicular. Or if they have neither, then they're just neither. So let's find the slopes. Line 1. M equals y2 minus y1 over x2 minus x1. And let's label x1, y1, x2, y2. Now, if for whatever reason you put your 1's first and your 2's second, that's okay. It's not going to actually change anything. I just do it this way. It's the way I've always done it. So y2 minus y1. 2 minus 0 over x2 minus x1, negative 2 minus 2. Following the order of operations, you do the numerator and you do the denominator first. So 2 over negative 6 is negative 1/3. That's the slope of line 1. Slope of line 2. M equals y2 minus y1 over x2 minus x1. I always write down the formula first so that I know that I'm using the correct formula. And label the points x1, y1, x2, y2, y2 minus y1. 4 minus negative 2 over x2 minus x1, 4 minus 1. 4 minus negative turns into 4 plus 2, so 6 over 3, a slope of 2. And that's where I'm going back. I'm double checking, making sure I've plugged things in correctly, and I do see a mistake. I got ahead of myself. Did you catch it? It's in line 1. Look for it. y2 minus y1 over x2 minus x1. Right here. x1. What was my x1 value? 2. I wrote down 4. This should be minus 2, which would make this negative 4, which makes this negative 1/2. So be careful. Label it down. If I see that you labeled x1 correctly and that you plugged in some weird number that apparently, I don't know what I was thinking, I'll at least know what was going on. I'll know that you knew what to do and for whatever reason just messed up. So look at these numbers, negative 1/2 and 2. Are they the same number? Exactly the same? No. One's positive, one's negative, one's a fraction, one's not. They're not the same number. Are they opposite reciprocals? One's positive, one's negative, and they are flipped. These lines are perpendicular because the slopes are opposite reciprocals. Example 2. Determine whether the lines are parallel and which lines are parallel and which lines are perpendicular. So let's see here. In order to know if they're parallel or perpendicular, we need the slopes. So it looks like we have line P, Q, R, S, and T. So for P, now we've got some options for calculating slope. We could actually use the slope formula. Here is a point on line P, and here's a point on line P. However, you'll notice I also put rise over run. There's a good chance your teacher used this language. A lot of teachers do. It's how far you go up and how far you go over. So in this situation, because we have the graph, I personally would count rise over run. So maybe from this point to this point. How far up did we go? We went up 1, 2, 3, and we went over 1, 2, 3. The slope is 3 over 3, which is equal to 1. What about Q? Q, this line here, goes through 0, negative 4, and 3, negative 1. Count rise over run. Go up 3 over 3. 3 over 3, which is 1. Let's do R. R goes from negative 2, 4 to 2, 1. Now it's going down 3 over 4. So negative 3 over 4. S goes from negative 2, 1 to 1, negative 2. That goes down 3 over 3, which is negative 1. And line T goes down 3 over 4. So, let's do parallel first. Are there any lines here that have the same slope, the same answer? P and Q. So P is parallel to Q. Any more that have the same slope? R and T. R is parallel to T. Are there any that have opposite reciprocals, where one's positive and one's negative and the number has been flipped? The answer is yes. It's the 1 and the negative 1. If you flip the fraction 3 over 3, you switch the numerator and denominator, flip that fraction over, you still get 3 over 3. So the reciprocal of 1 is just 1. P is perpendicular to S, and Q is perpendicular to S. 1 and negative 1 are opposite reciprocals. Now, example 2 is good practice for calculating slope and counting, recognizing numbers that are the same or opposite reciprocals. Example 3 and example 4 are the types of problems you would see on the final exam. So, example 3. Write an equation of the line passing through the point 3, negative 2 that is parallel to y equals 2/3 x minus 1. And then we're going to skip the graphing and just focus on the actual equation. So, first thing I want you to know, or do, is identify whether it's parallel or perpendicular. Parallel. And what I'm going to do is I'm going to go ahead and write down parallel means what about the slope? Parallel means they will have the same slope. Parallel means same slope. And I'm writing it down so I don't forget that that's what we're doing. Now, they gave us a slope. The given slope. Look at this graph right here, this equation, y equals 2/3 x minus 1. What is the slope in that equation? The slope, remember, it's in this form right here, y equals mx plus b. The slope is the number between the equal sign and the x. Between the equal and the x. So what is the slope between the equal sign and the x? Is 2/3. That's the slope they told us. So, what slope should we use when we solve this problem? Well, parallel means we need to use the same slope. They told us 2/3, so we should use 2/3. They also told us a point to use. What point did they tell us? 3, -2. Once we have a point and we have a slope, we're going to use point-slope form, which from the front page is y minus y1 equals m parenthesis x minus x1. Y minus. Y1 is the y value of your point. Well, here, use the point 3, -2. Which one's the y value? -2. M is the slope we are supposed to use, and it says use slope 2/3, so 2/3 parenthesis x minus x1 is the x value of our point, 3. Now you do need to actually solve this and simplify it all the way down to where it looks something more like the original form. So this is y plus 2 equals, let's distribute. Now it turned into plus because of the minus the negative. 2 negatives make a positive. So 2/3 times x is 2/3 x. 2/3 times -3 is -2. Last step, get y by itself by subtracting 2 from both sides, and you get y equals 2/3 x minus 4. Notice the slope is still 2/3, and if you were to plug in 3, which is our point here, you should get -2, which is the y value. Example 4 is a very, very similar example. The difference, the big difference is this word right here, perpendicular. So much of this process will look the same, but there'll be a few small changes. So write an equation of the line passing through the point P, -2, 2, that is perpendicular to y equals 2x plus 3. So just like before, I started with parallel means the same slope. I'm going to do the same thing here. Perpendicular means what did perpendicular mean? Perpendicular meant opposite reciprocal. Perpendicular means opposite reciprocal. Great. The given slope. The given slope, use point slope form. Those are all the same here. We just got to make sure we account for the fact that it's perpendicular. So the given slope. What slope did they give us in this equation right here? The slope is the number between the equal sign and the x. That's the 2. So use slope 2. Sorry, the given slope is 2. What slope should we use? Well, perpendicular means opposite reciprocal. So we need the opposite reciprocal of 2, which is -1/2. What point should we use? Well, you don't make up your point. You use the point that they tell you, which is -2, 2. And then we're going to use point slope form. y minus y1 equals m parenthesis x minus x1. And we're going to fill in the slope where m goes, and the point is x1, y1. So y minus, what's the y value of our point? 2. What's the slope we are supposed to use? Negative 1/2. And how do we know to use this one instead of the 2? It's because I wrote use slope in front of it. I put the word use in front of it. Not because I personally need it there, but because it's a way to help remind myself as I go through this that this is the one I'm supposed to be using. X minus, what is the x value of our point? Negative 2. So I'm going to, before I distribute, I hate minus negatives. I prefer to put x plus 2 to clean it up a little bit. So let's see, let's distribute the negative 2. Y minus 2 equals negative 1/2 x. Negative 1/2 times 2 is negative 1. Add 2 to both sides, and y equals negative 1/2 x plus 1. It's really important that you remember that parallel means the slopes are the same, and perpendicular means that they are opposite reciprocals. But at this point in time, you should have enough information to do your homework for section 3.5.